Having introduced some basic trigonometric functions, we'll now look at a few very important examples. These are the 30-60-90 triangle and the 45-45-90 triangle. Why do I say that these are important? Well, they're important because you can compute the trigonometric quantities related to them easily without a calculator. So this is something that's very important for the Precalculus CLEP exam because there will be times when you won't have a calculator. So let's start with the 30-60-90 triangle. The name is referring simply to the angles of this triangle. So one angle, of course, is 90 degrees. These are all going to have at least one, well, exactly one angle of 90 degrees because they're all right triangles. The 30-60-90 triangle, though, has the other angles as 30 and 60. So I'll say that this one is 60 degrees and this one is 30 degrees. So what's so special about this triangle? Well, if I put 1 here, it can be shown, we will not, but it is a nice exercise to prove that the other sides are necessarily 1/2 and square root of 3 over 2. So what this means is that it's fairly straightforward to compute the sine, cosine, and tangent for this triangle because all of the side lengths are things you can commit to memory. And in fact, you should. You should know that the 30-60-90 triangle has side lengths of 1/2, square root 3 over 2, and 1, respectively. So I'll draw the picture just again here. So as soon as this side length is 1, this automatically becomes, let's call this 60 and let's call this 30. This automatically becomes square root 3 over 2, and this automatically becomes 1/2. So for computing the trigonometric functions for this, we just do the opposite and adjacent rule. So for 30 degrees, sine of 30 is opposite 1/2 over 1. So 1. Cosine is adjacent over hypotenuse, so square root 3 over 2 over 1, so square root 3 over 2. And then tangent is opposite 1/2 over adjacent, square root 3 over 2. So this one I'll write out, it's opposite over adjacent. So 1/2 divided by square root 3 over 2, which is 1 over square root 3. And we do the same thing for 60 degrees. So sine is opposite over hypotenuse, so square root 3 over 2 over 1, square root 3 over 2. Cosine is adjacent over hypotenuse, so 1/2 over 1. And then tangent is opposite over adjacent. So again, this one's a little bit more delicate, so I'll write it out. So just square root 3. So that's the first sort of what you might call a special triangle that you should really have committed to memory. The second one is the 45-45-90 degree triangle. Now this is special because not only is it a right triangle, it's also isosceles, meaning that two side lengths, namely the two legs of the triangle, have the same length. So it's really quite a simple picture. So 45, 45, 90. And because these two angles are the same, the sides opposite to them must also be the same. This is just a basic result in geometry. So this length is the same and this length is the same. So in fact, it's also isosceles. So we can also compute the necessary side lengths of this triangle. If this side is 1, then it can be easily shown that the other two side lengths must be 1 over square root of 2. Of course, they'll be equal, and they are equal to 1 over square root 2. I mean, this can be seen just from the following simple calculation, that if I called them both a, they have to be equal, I mean, of course. So I know that from the Pythagorean theorem, 1 squared equals a squared plus a squared. So 1 equals 2 times a squared. So 1/2 is equal to a squared. So a is equal to 1 over square root 2. So with this in mind, I can again compute sine, cosine, and tangent rather easily. Sine is opposite over hypotenuse, so in this case 1 over square root 2. Cosine is adjacent over hypotenuse, but the opposite and the adjacent are the same in this case. So this is when sine and cosine are equal. They're both equal to 1 over square root 2. And then tangent is opposite over adjacent. So in this case, opposite and adjacent are equal, so I just get 1. Right, so this is opposite over adjacent, so 1 over square root 2 over 1 over square root 2, so 1. So the 30, 60, 90 triangle and the isosceles right triangle, 45, 45, 90. These are the special triangles that it's very helpful to understand before doing anything kind of cool with your calculator.